Dragon is in countdown. Falcon 9 is in startup. Dragon, SpaceX, go for launch.
And we are back, showing you another live look of SpaceX's Falcon 9 rocket and Cargo Dragon here at Pad 39A at Kennedy Space Center. Yesterday's launch was scrubbed because of weather. We're going to try again in just about 14 minutes. Thank you for waking up with us again this Sunday morning. I don't know what day it is, guys. I'm Megan Cruz with NASA Communications, live from Kennedy Space Center in Florida. Today's launch at 3:14 a.m. Eastern Time is SpaceX's 23rd cargo resupply mission for NASA to the International Space Station. We are again simulcasting this live show on NASA TV and on SpaceX's webcast. Let's bring in Andy Tran now, live from SpaceX's headquarters in Hawthorne, California. Andy, I know you're also hoping for some better weather today, and it looks like we have it.
Yeah, we are definitely continuing to keep an eye on the weather. If it does cooperate, this will be the third Dragon flight to the space station this year, and also the third cargo resupply mission with our upgraded Dragon. Following a successful launch, this Dragon will be joining the Crew 2 vehicle Endeavour, currently on orbit and attached to the International Space Station. For now, let's take a closer look at the vehicles out on the pad. On screen right now is a view of Dragon, and that is a view of Falcon 9 underneath it. It is a reusable two-stage rocket designed and manufactured by SpaceX. The bottom two-thirds of the vehicle is the first stage. Its objective is to accelerate the vehicle through the Earth's atmosphere to space and then separate from the rest of the rocket. This is going to be the fourth flight for today's first stage, which actually previously supported both the Crew 1 and Crew 2 missions for NASA. We are going to be attempting to recover the first stage again with our brand new drone ship named a Shortfall of Gravitas. There it is on screen. Above the first stage is the second stage. It has a single Merlin vacuum or MVAC engine, which ignites after the first stage separates. The second stage is what will carry Dragon to its intended orbit, allowing the spacecraft to eventually rendezvous with the International Space Station. And as we saw previously, Dragon is the spacecraft sitting on top of the rocket. To this day, Dragon remains the only spacecraft currently flying that's capable of transporting significant amounts of cargo to and from the Earth. So that's a little bit about our Dragon and Falcon 9 vehicles. Back to you, Megan.
Thank you, Andy. And now I want to bring in Joshua Santora, also with NASA Communications. Joshua, can you walk us through yesterday's weather concerns and again, just how much better it's looking today?
Yeah, Megan, as you said, it is looking so much better today. Appreciate that. And so yesterday we had a lot of concerns happening really close to launch. And as is the case with all weather concerns, it just takes time to get past them. And that's what we saw yesterday is we didn't have enough time. And so we were concerned about things that either actual natural lightning or generating lightning as we flew through the atmosphere. And so that really kind of forced us to wave off yesterday's attempt. Today, things are looking phenomenal. Take a look here. This is only a 20% chance that we would have a violation of our launch constraints, which means we are 80% go on weather. The only things we're watching are some clouds in the area and the potential for precipitation, but by and large, we're extremely optimistic, now targeting launch in about 11 minutes from now. That report coming from the Space Launch Delta 45 folks with the Space Force. Appreciate Launch Weather Officer Brian Cizik walking us through that. And then the range taking care of public health and safety as well, the land around the launch pad, the water over which we fly, the air we fly through, and the space we're headed to, doing the collision on launch avoidance assessments, and those all look clear. So we are on track for our liftoff on time at 3:14:49 a.m. Eastern Time. That timing is so precise because we have a single second in order to be able to rendezvous with the space station, currently traveling at 17,500 miles an hour, and we're set to rendezvous and dock tomorrow morning, Monday, at 11 a.m. Eastern Time, with our coverage beginning at about 9:30 a.m. Eastern Time. So, Megan, technically really quiet, weather looking really solid. Everything is go at this moment. That's it for now. Back to you.
I'm loving your update, Joshua. Thanks for that. All right, T-minus 10 minutes to launch now. How about we take a look at some of the science flying to station today?
What do ants, plants, a remote implant, and brine shrimp all have in common? They're all part of investigations sponsored by the International Space Station U.S. National Laboratory, launching on SpaceX's 23rd Commercial Resupply Services mission. Moreover, these projects will be supporting the validation of the Faraday Research Facility, a new commercial research facility operated by Proxops that is flying on this mission and will provide additional avenues of experimentation for future investigators. Specifically, the Girl Scouts of Citrus, in conjunction with Space Kids Global, will launch 3 different student-led investigations, all evaluating the characteristics of living organisms in low Earth orbit. One experiment will examine microgravity's effects on ant behavior. Another will look at plant growth in space, and the last will explore how brine shrimp move and behave in the low Earth orbit environment. A team of researchers from Houston Methodist Research Institute is also launching an investigation on this mission that will utilize the Faraday Research Facility. This team has a long and exciting history of space-based R&D in areas ranging from nanofluidics to drug delivery technology development, rodent research, and advanced materials. These research projects have led the team to its latest investigation that will aid in the development of a tunable drug delivery implant. The implant can be remotely controlled to release specific amounts of drug, providing individualized treatment for patients on Earth. These are only a few of the ISS National Lab sponsored projects launching on SpaceX CRS-23. Research sponsored by the National Lab aims to bring value to our nation and drive a robust market in low Earth orbit. To learn more about all investigations sponsored by the ISS National Lab flying on this mission, please visit our mission overview page at issnationallab.org.
All very interesting and really a wide variety of science. Researchers use the unique opportunity to study things in microgravity to hopefully uncover ways to improve human spaceflight or how we do things here on Earth. Some of today's experiments were loaded onto Dragon just right before yesterday's launch attempt. You can see video there of what we call that late load. Each person is carefully handling the time-sensitive experiments that needed to be packed into Dragon as close to launch as possible. But what happens to the science once it arrives at the space station? Let's take a look at a special tour we shot just for you guys with the astronauts on board.
Hello and welcome aboard the International Space Station. I'm NASA astronaut Megan MacArthur along with my crewmate Shane Kimbrough. We are getting ready for the SpaceX 23 cargo mission coming up soon, and we're very excited. It's going to be keeping us pretty busy.
Hey Megan, let's go show them around the space station a little bit and we'll show you where some of these experiments are going to be done. Welcome to the European module called Columbus. This is where a lot of the SpaceX 23 experiments are going to hang out. One of those is called Apex 8, which is going to study the response to stressors at the genetic level of plants. Now they're going to be really small plants in petri dishes that we're going to eventually put into this facility here that's called Veggie. It's a veggie plant growth facility. On my last flight, I got to grow lettuce in here, and we got to actually harvest that and eat it, so that's pretty cool. One of the things we're trying to do is to learn how to engineer plants to grow better in microgravity, and what we learn from that will be able to help us in the future in space travel, but also help people on Earth grow things better. This isn't the only facility we have on the International Space Station to grow things. We have an advanced plant habitat, and currently we're growing chili peppers in there, which we hope to harvest towards the end of our mission.
So now we're in the U.S. laboratory, which is called Destiny, and this is one of our main areas for conducting science on the International Space Station. One of the things that makes the International Space Station such a versatile research lab are the express racks. There's a couple of them right here over my head, and the cool thing about these is that it allows different researchers from around the world to send up their own payload, and the express rack provides the power and data, cooling, whatever that particular payload needs. One of the new facilities that will be coming up on SpaceX 23 cargo mission is called the Faraday Research Facility, and it's able to house 4 different experiments at once. 3 of them will house small organisms. The 4th experiment will be a medical experiment to look at remote-controlled delivery of medication. So that will be an interesting technology demonstration as well, and we'll be able to install that facility into one of our express racks here in the laboratory.
And that was NASA astronauts Megan McArthur and Shane Kimbrough aboard the International Space Station. And welcome to the International Space Station Flight Control Room. I am Shaniqua Vereen, live at the Johnson Space Center here in Houston, Texas. The team of flight controllers at Mission Control Houston today is being led by Flight Director Rebecca Wingfield. Teams here at Mission Control will really jump into action tonight into early Monday morning as Cargo Dragon approaches the International Space Station. There are currently 7 crew members living and working aboard the station. Expedition 65 consists of NASA astronauts Shane Kimbrough, Megan McArthur, and Mark Vandehei, Roscosmos cosmonauts Pyotr Dubrov and Oleg Novitsky, Aki Hoshide of JAXA, and Thomas Pesquet of the European Space Agency. As Crew Dragon approaches the International Space Station in the morning hours on August 30th, NASA astronauts Shane Kimbrough and Megan McArthur will be monitoring the arrival from the station's cupola. Cargo Dragon will remain attached to the International Space Station for about 1 month before being packed up with critical science and supplies and will splash down in the Atlantic Ocean or the Gulf of Mexico for that science to be analyzed back here on Earth. Everything's still a go from here in Mission Control Houston, and we're looking forward to welcoming another vehicle to the International Space Station. So for now, we'll head back out to Kennedy. Megan?
Great, Shaniqua, thanks. Let's get one last status update from Andy and Joshua before the final moments of the countdown. Guys?
Thanks, Megan. We are about T-minus 3.5 minutes until liftoff. The SpaceX team is working no significant issues. Right now, we are expecting the strongback to be reclining away from the rocket to its pre-launch position, about 2 degrees away from Falcon 9, in order to prepare for liftoff. That strongback is part of the transporter erector. You can see on screen right now, it's starting to recline away from Falcon 9. The transporter erector is that large truss structure next to Falcon 9. Its job is, again, to retract away from the rocket and prepare for liftoff. At this point, RP-1 fuel is completely loaded on the second stage and nearly completely loaded on the first stage. Liquid oxygen loading is currently underway on both stages and will complete around the T-minus 2-minute mark. In these last few minutes, Falcon 9 is performing final health checks on its primary communications, avionics, and propulsion systems in preparation for flight.
Dragon is undergoing vehicle health checks, and we did hear the call out at T-minus 5 minutes for internal power. Switch to internal power, meaning it's living on its own, apart from ground support systems, which is great. We're also expecting right now the checkouts of the second stage thrust vector control actuators are underway. This is what we affectionately refer to as the engine wiggle test. Not very technical, but definitely kind of describes what we're talking about. We're moving the nozzles of those engines on the engine on the second stage to ensure we have control for the uphill climbing and navigating that vehicle. That's just part of making sure the guidance hardware is go for flight. SpaceX will do the exact same thing for all of the first stage engines just a few seconds before ignition. All of this in preparation for our rendezvous with Space Station tomorrow morning. And Space Station right now we're on approach for. We're catching up to.
Launch load complete.
Is just over the south edge of Australia as we speak.
Dragon is in auto idle.
And we just heard the call out that LOX load has been completed. That will wrap up propellant loading for the vehicle. You can start to see some white clouds forming around Falcon 9 and Dragon. That is normal and expected for us at this stage in the countdown. That is super chill liquid oxygen starting to condense as it reaches the warmer ambient air temperatures of Florida.
Through the rest of the countdown, we're going to hear a few call outs, but by and large, we'll just listen in here and walk through as Dragon finalizes its preparations and the team verifies we're go for launch.
Falcon 9's in startup.
Dragon is in countdown.
Both stages are now pressurizing for launch. Range and weather should both be good to
Falcon
go.
9, CRS-23, go for launch.
That was the voice of the launch director verifying we are go.
T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Cargo Dragon takes flight, continuing a busy year of deliveries to a crew of 7 aboard the International Space Station.
Stage 1 chamber pressure is nominal.
We are 50 seconds into flight. Falcon 9 has cleared the tower and is currently headed to space. In about 15 seconds here, we're coming up on max Q. This is where the vehicle will experience the highest amount of aerodynamic pressures. And there was the call out for max Q. We actually throttled down the Merlin engines in preparation for that event. Coming up are 5 more events in rapid succession. Main engine cutoff, stage separation, first stage flip, second engine start 1, and then the boost back burn on this first stage will begin. Main engine cutoff, also known as MECO, is where all 9 M1D engines on the Falcon 9 first stage will shut down. This is followed by stage separation, or the separation of the first and second stages. From there, the first stage will flip to prepare for re-entry and landing a few minutes later. And the Merlin vacuum engine on the second stage will ignite to boost Dragon to low Earth orbit, and that's also known as SES-1. The first stage will then begin its boost back burn. That is the first of 3 burns needed to land on our drone ship today. The first of those 5 events, main engine cutoff, is coming up in about 10 seconds.
Main engine cutoff.
Stage separation confirmed.
INVAC ignition.
Stage 1 boost back burn startup.
Okay, those were those 5 events. A lot happening on screen. Main engine cutoff, stage separation. The first stage performed a flip. Second stage on the right-hand side of the screen ignited its Merlin vacuum engine. And on the left-hand side of the screen, we're in the middle of that first stage boost back burn. Looks like we are getting some really cool views
Stage 1
of
boost back shutdown.
contrails being produced by the first stage. And that was the call out for the successful completion of our first of 3 burns on the first stage. So if you're just joining us, you're watching a live webcast of the 23rd commercial resupply mission to the International Space Station for NASA. This is SpaceX's 21st mission this year, and this is the cargo configuration of our Dragon spacecraft.
Acquisition of signal at Bermuda.
You might be interested to know, in order to get into space, the rocket has to do more than just go up. It actually has to go sideways really, really fast. At liftoff, gravity is pulling straight down the rocket, and as we ascend, we tilt the engines. That turns the rockets horizontally. Now, we're still going up, but we're also heading horizontally away from the launch pad in what we call a gravity turn. The rocket typically needs to go about 7.5 kilometers per second, or 17,500 miles per hour horizontally, in order to avoid being pulled back down to Earth and get into orbit. On screen again is the view of the Merlin vacuum engine on the second stage. On the opposite end of that engine is our Dragon. Next event for today's mission is the re-entry burn for the first stage. That's the second of 3 burns. This is where 3 of the Merlin engines will reignite, and this helps to slow down the stage as it re-enters the upper parts of the Earth's atmosphere. And that the beginning of that burn is happening in just under a minute. Seems like we've lost the video footage of the first stage. Hopefully we can get it back in order to see that re-entry burn. But on the bottom left-hand side of the screen is a speedometer of sorts tracking the velocity of the first stage. As we begin that second burn, watch for that speed to slow down, and definitely once we hit the denser parts of the atmosphere, we'll start to see the speed slow down quite significantly.
Stage 1, entry burn startup.
And there is the beginning of the entry burn. 3 Merlin engines have relit and are currently slowing down the first stage.
Stage 1, entry burn shutdown.
Awesome. That is the successful completion of the second burn. We are about 60 seconds away from landing, and the vehicle is traveling about 900 miles an hour. This really puts into perspective the deceleration. In the span of less than a minute, we'll have reduced the speed from the speed of a jet all the way down to 0 as the rocket lands. And again, this is our brand new drone ship, a shortfall of Gravitas. This is going to be the first time that we are making a landing attempt on it, and it's currently perched out in the Atlantic Ocean waiting for that first stage booster to return to it.
Stage 1, landing burn startup.
A single engine, the center engine, engine number 9, has relit in preparation for landing.
Stage 1, landing leg deploy. Stage 1, landing confirmed.
And that is the 90th successful landing for an orbital class rocket, and the very first for our new drone ship, a shortfall of Gravitas. That is a beautiful thing to see and a great way to start off today's mission. Next event coming up is for the second stage. The Merlin vacuum engine will shut off its engine in an event called Second Engine Cutoff, also known as SECO. And shortly after SECO, we'll be entering a coast phase and waiting for that confirmation of a good orbit.
SECO.
Nominal orbit insertion.
And we did get confirmation of both SECO, second engine cutoff, and a nominal orbital insertion. Now, the second stage has one last major task, and that is commanding separation of Dragon a couple of minutes from now. Again, this is the second flight for this particular Dragon and the first reuse of our upgraded cargo vehicle. We should have video of Dragon separation from the top of the second stage. It'll give us a nice view into Dragon's unpressurized cargo trunk. And when this Dragon makes its way to the International Space Station, it will be joining the Crew 2 vehicle Endeavour currently on orbit and attached to the International Space Station. It's going to be super cool to see 2 Dragons docked to the International Space Station once again. And again, for cargo, we will be delivering over 4,800 pounds of science, research, crew supplies, and vehicle hardware to the orbiting laboratory and its crew. This includes the brine shrimps and ants that we had talked about earlier in the broadcast. Now, the science and research being done in microgravity on the International Space Station has benefited our lives here on Earth for decades. What's really cool is that our new Cargo Dragon vehicle is also able to act as a laboratory in the advancement of this science and research. We call this capability Extend the Lab. It allows some powered payloads to remain on Dragon for experimentation during the duration of the mission. This is especially helpful when there is limited to no space on station for additional science, and it also helps cut down the amount of time the crew has to move payloads in and out of Dragon. For CRS-23, there are 3 Extend the Lab payloads launching with the mission, and once docked, a 4th, which is currently already on the space station, will be added to Dragon. So we are about a minute away from that separation from Dragon from the second stage. For now, we are enjoying some views of the second stage Merlin vacuum engine. We can talk a little bit about the upgrades that have been made to Dragon. The first is solar arrays. Typically, after separation, we wait for solar arrays to unfurl from Dragon. This upgraded Dragon has been redesigned, and the solar arrays has its panels built into the trunk section itself, providing power during flight and while on board the station. Another upgrade is how we dock. Before, we needed Dragon to be berth, which is where a robotic arm from the International Space Station reaches out and grabs Dragon and will attach it to the International Space Station. Now, Dragon can autonomously dock using a centerline camera and LiDAR, which is an acronym for light detection and ranging. And so this autonomous docking sequence is what Dragon will go through in the short future as it continues to make its way towards the International Space Station.
Operation confirmed.
And that is a great view of Dragon separating from the top of the second stage. Now the service section Dracos will undergo some checkouts. Coming up is the beginning of the nose cone opening sequence. I'm going to hand it over to Shaniqua in Houston to talk a little bit more about that.
Thanks, Andy. Everything is still going well back here in Houston and Mission Control Houston. Right after Dragon separated, it began a series of automatic checkouts, including some small firings of the Draco maneuvering thrusters. The next milestone is the nose cone deploy. The nose cone protects the docking hardware and rendezvous and tracking elements on top of Dragon during ascent. The nose cone deployed uncovers the 4 forward bulkhead thrusters, which Dragon will use for its major burn maneuvers to catch up with the space station. Once open, the nose cone will stay in that position until the very end of its mission, closing prior to re-entry to provide some additional protection to that same hardware during re-entry. And we currently are waiting for confirmation for that nose cone to be deployed. And if you're just joining us, we're in Mission Control Houston currently, and we're waiting for the confirmation of nose cone deploy for Cargo Dragon. And as we still wait, we do have a special guest. Now joining me on the phone is manager of the International Space Station Systems Engineering and Integration Office, Jeff Aaron. Jeff, can you outline the major activities for the crew with CRS-23 for us?
Sure can. In a word, they're going to be extremely busy conducting research. There's more than a metric ton of research arriving with SpaceX 23, much of which needs to be removed in hours to days to start the science and research mission, because most of which will be completed in the entire 30-day mission while SpaceX is on orbit. And then much of that science needs to return with the vehicle upon its departure. So in addition to the research mission, the crew will be conducting 3 EVAs over a 10-day period of time, 2 EVAs on the Russian segment where 2 new power cables will be installed to enable additional power transfer to the new module, the module that just arrived actually a month ago today, the multi-purpose laboratory module, and 1 EVA on the U.S. segment to install the 3rd IROSA mod kit, which will enable a future solar array upgrade on the U.S. segment.
Thanks, Jeff. And I know you mentioned a lot about the science and the hardware that's going up, but how critical are these deliveries for the station and for the astronauts aboard?
Yeah, these commercial resupply missions are very, very important to continue advancing science aboard the space station. Over 3,000 experiments have been conducted during the station's lifetime, which we're now approaching, coming up on 21 years of continuous human presence. On this flight, SpaceX is packed with more than 2 metric tons of supplies, research, technology demonstrations, and hardware. The crew will stay busy unpacking and conducting these research activities, with the first several days being extremely critical for several experiments: the Faraday Research Facility, ESA Biofilms, and Tango Lab.
And you mentioned, Jeff, as always, it's a busy time aboard the International Space Station with cargo vehicles and crews coming and going. You mentioned the 2 Russian spacewalks that are quickly approaching us. How complex will the next few months be for the station program and the global partnerships?
Yeah, it's always a complex time on ISS. And SpaceX 23, as I think you pointed out earlier, it arrives tomorrow. So 30-some hours, when I'm trying to do real-time math here, 28 to 30 hours later. But 10 a.m. Central is when SpaceX will arrive. Following docking to the Node 2 forward port. And oh, by the way, this is the first cargo vehicle that will be docking to the forward port. The hatch will be opened about 2 hours later. And then the crew still has several hours of unpacking to do to begin the research program. And although the first EVA isn't until Friday of this week, the crew has already begun preparing for each of these upcoming spacewalks, which include suit preparations, tool gathering and packing, procedure reviews, and personally a lot of self-study for the astronauts. There will be 2 on the Russian segment, as you said, and 1 in the U.S. segment, all over a 10-day period of time. So it's a very busy time, but as I kind of said up front there, it's kind of like that every day on ISS. So very exciting times.
Thanks, Jeff. All right, and thanks so much for joining us today. Back here in the International Space Station Flight Control Room, flight controllers are monitoring the systems on the station itself ahead of Dragon's arrival Monday morning. Once Dragon crosses that approach ellipsoid, which is the mythical sphere around the station, flight controllers here in Mission Control Houston will begin joint operations with the SpaceX teams in Hawthorne, California. NASA astronauts Shane Kimbrough and Megan MacArthur will be monitoring the approach and arrival of Dragon with a planned docking Monday morning at 10 a.m. Central Time, 11 a.m. Eastern. Once Cargo Dragon is docked to the station, MacArthur and Kimbrough will begin those hatch operations that Jeff mentioned. And between the International Space Station and Cargo Dragon, the hatches will be opened. Again, everything's still on track on the International Space Station side. So that'll do it for us here in Mission Control, Houston. Now back over to Kennedy. Megan?
Thanks, Shaniqua. That's going to wrap up our launch coverage of SpaceX's 23rd commercial resupply services mission. Cargo Dragon is on course to dock to the International Space Station at about 11 a.m. Eastern Time tomorrow. We will have live coverage of rendezvous and docking beginning at 9:30. In the meantime, you can learn even more about this mission on nasa.gov commercial resupply. Thank you for joining us, and we'll leave you with a replay of today's gorgeous launch.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Cargo Dragon takes flight, continuing a busy year of deliveries to a crew of 7 aboard the International Space Station.
Stage 1 chamber pressure is nominal.